Hi Geometry, welcome to 11.1, Circumference and Arc Length. So chapter 11, basically all about circles. And actually you will prove circumference, arc length, area, volume of a sphere, all that stuff when you hit calculus. In the meantime, you just have to trust me on it and kind of memorize these formulas. So here we go. I can find my learning targets, I can find arc lengths and other measures on a circle, and I can apply them. So such as finding the length of a track and RPM. So here we go. Simplify the expression. Basically, we want to reduce these. And what can you take out of both of these? A 45. 45 goes into 45 one time. It goes into 360 8 times. Do you remember how to do that on the graphing calculator? I just realized I don't have my graphing calculator with me. So let me know if you need help with that. All right, so first of all, how about part B? How many 120s go into 360? 3 of them. Then, how many 3s go into 9? 3 of them. You're left with a 3 and a pi. Leave your answer like this. This is exact answer format. If you take 3 times 3.14 blah, 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 then you have an estimated answer, okay? Because we know pi goes on forever. 1 billion digits. Now, how many 3s go into 15? 5. So the answer here is 5 pi. And how many 6s go into 360? Well, I know the zeros can cancel. How many 6s go into 36? 6. Then what can go into 6 and 15? 3. So you're left with 5 pi over 2. Okay? And again, that's an exact answer. It's unusual to write this as 2.5 pi. That's correct, but usually if you have a decimal and an irrational number, you can keep it in fractional form. All right, so definitions. The circumference C of a circle is, let's get a highlighter for this, or, okay, why are all my highlighters missing? So we're going to have to use purple. It's either pi d or 2 pi r. That means d is the diameter and the radius r is the radius of the circle. So basically, if you put 2 radii together, a radius goes from the center to the edge. So if I go from the center to the edge, I have 1 radius, and then to the other edge, I have 2 radii. That's equal to 1 diameter. So keep that in mind. We need to know this formula. C is equal to 2 pi r. I know most people do memorize it as pi d, but that's fine. I always use this one. Okay, so find the indicated measure, the circumference of a circle with the radius 15. So remember, C is equal to 2 pi r, and the radius is 15, so I have 2 pi times 15. Well, 2 times 15 is equal to 30. So the answer is 30 pi, and then put it as inches. This is the exact answer. Why am I using purple? If that's 30 pi inches. Let me go over that so you can see that better. If you put this in the calculator and find the decimal answer, it's approximately 94.25 inches. Okay? How about this? The radius, find the radius when the circumference equals 36 feet. So C is equal to 2 pi r, and the circumference is 36, so I'll substitute 36 in for C. Now r is being multiplied by 2 pi, so I'm going to divide both sides by 2 pi. This is my exact answer. Of course, if I reduce the 36 and 2, I'd have 18 over pi. But that answer is, here, I'm going to write 18 over pi, and then put a wave. If I put that in the calculator, you get about 5.73 feet. Please double check these with the calculator, because I really don't know if they're correct. I haven't double checked myself. All right, what is the relationship between the circumference of a tire and the distance covered in 1 revolution of the tire? Okay, so let's say this is our tire. We've got some spokes. Did you ever go to the Food Spokes and Folks Festival in the summer? It's kind of nice. Okay, we know that circumference goes all the way around, right? And C is equal to 2 pi r. And if I cut right here, right, it'll make a straight line. That straight line will be the circumference. So 1 revolution is the circumference, so they're the same. All right, next page. Ooh, color. It's pretty. Of course, yours comes out in black and white. Sorry about that. All right, arc length, corollary. So in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of, that's weird, the measure, the arc to 360. So the measure of the arc to 360. So in general, the angle of the sector. So let's say we know that this angle here, S stands for arc length. You're going to take 0 divided by 360 is equal to 2, or times 2 pi r. Okay? So whatever this angle is, say that was 50 degrees, we put 50 over 360 multiplied by 2 pi r, and they'll tell us our arc length. Now keep in mind, this is the formula in degree mode. It's got to be in degrees. Okay, the reason I point that out is because when you are taking upper level math, everything will be measured in radians. So notice we have to kind of fix that there. So if it's measured in radians, this is your formula. So this one would be in radians. Remember I told you, like, if you're measuring a distance, you either have like centimeters or inches. Well, if you're measuring in the angle, it's either in degrees or radians. So you will be using all radians in upper level math. You'll be using degrees right about now. So here we go. Find the length of each arc. So basically what I'm looking for is this length. And remember, for some reason they notate it with an S. I really don't know why. So S is equal to, the formula's up here, theta, which is 60, over 360, times 2 pi times 9. All right, so then you just clean this up. This is going to be 1/6, and 2 times 9 is 18. 6 goes in 18 3 times. So 1/6 times 18 pi. 6 goes in 18 3 times. There is your exact answer. Of course, I don't know what units they are. Remember, this is a distance, so it's some unit. How about this one? S is equal to the angle, which is 115, over 360, times 2 pi r. And the r is 5. So 115 over 360, and again, I'll remind you how to do that in the calculator to reduce it. You're going to get 23 over 72 times 10 pi, and that is about approximately equal to 115 pi over 36. This one gives us a unit, so centimeters. This is the exact value. If you put it all in your calculator, 115 times pi divided by 36, you'll have your rounded answer. How about this one? No units here. S is equal to the angle divided by 360, so I have 100 divided by 360 times 2 pi r, which is 3. So 100 over 360, that will reduce totally to 5 over 18 times 6 pi. 6 goes in 18 3 times, so this will be 5 over 3 pi. And again, I don't know what the unit is. So far, so good? Okay, now, let's go backwards. What if the arc length is 4 pi? Find x. So, 4 pi, okay, notice what I'm doing with the formula. I'm writing 4 pi equals, I don't know what that angle is, over 360 times 2 pi r, which is 6. Okay, so let's see here. I kind of cleaned it up. I'm running out of space here, if you're going to trust me. X is equal to 120 degrees. Please double check that. All right. Oh, it says also find the circumference. C is equal to 2 pi times 6, which is equal to 12 pi. That's our circumference. Okay, how about this one? I'll do the work over here. 40 equals, okay, so the arc length is 40 to AC, so this is 40. The R is 15.28. Yeah, go figure. So we now want to find the measure of the angle. So we have 40 is equal to x over 360 times 2 pi 15.28. So trust me or double check, I get about 150 degrees. Okay? What do you think? So far so good? Yeah, the reason I know these answers without my calculator, I do all this work ahead of time. Last but not least, and thankfully this is still recording. Nothing like having to do these twice. Okay, so hopefully it's not hard to see that track. And since both of you are in track, and I know you're not going to tell me when your next track meet is, so I'm going to try to figure it out myself. I'll root for you, pom-poms. The track and soccer field shown below. The track lane forms a 180-degree arc of a circle. Okay, so, from like right here, actually if I put this down, this is like half a circle, and then this would be half a circle. On each end of the track, the radius of the inner arc is 80. Do you see that? That's 80. And the radius of the outer track is 120, so this is 120. Find the distance around the track to the nearest foot for a runner using the middle of the track. All right, so this is what I did. So I said arc length is equal to, I'm just going to find one of these, okay? The arc length is 180 divided by, because remember that whole angle is 180, divided by 360, that's a bad 6, times 2 pi. What am I use for radius? What's in between 80 and 120? How about 100? So we're going to use 100. 2 pi r. So we're going to get about, okay, I'm saying, I don't know if that's exactly 100, but I'm saying it's about 100 pi. Okay? Now, I have to multiply by 2. Why? For each corner, or each side. So I have times 2, that would be 200 pi. Am I done? No, that's for the curves. So how about the straightaway? So each one is going to be 300. So I have 300 times 2. That's 600. So take this plus this. That would be the distance of your track. So 200 pi plus 600 is about 1,228 feet. Of course, what makes it more interesting is they don't do this in feet for your track meets. I believe they do it in meters. But we can actually convert it later. But in any case, here's our homework assignment and our Common Core standard. But have a nice evening, and hopefully, Alex, you're doing okay, that your braces don't hurt too much.